Welcome to EDU World Space.
Okay, so we are doing a CLAISEN condensation. This is going to be a self-CLAISEN because there's only one reactant, right? And I think what's kind of neat about CLAISEN condensation is that there's a fun little trick that you can do. And I can just kind of illustrate that here. I'm going to draw a second reactant, right? Because we're going to need two of these if we have a CLAISEN condensation. What you basically think about doing is identify the alpha carbon on one of them. Okay, there's my alpha carbon. Great. And now we're going to identify the carbonyl of another. I'm just going to put a C there for carbonyl. I'm going to use another color to just chop off the ester portion. That's just going to go away. And then pretty much all that's left to do with a reaction like this is to join the alpha carbon and the carbonyl of the other ester. So we're going to join those two atoms, right? And everything else will pretty much remain as is. So I'm going to redraw, right, the original ester. Like so. Okay. Then remember we said this was our alpha carbon. Okay. So we're going to have a bond from that alpha carbon to this carbonyl carbon. So now I'm going to number the carbons starting from the carbonyl carbon. We'll call that 1, 2, 3, 4. And that tells me that attached to this alpha carbon, I need a 4-carbon chain. 1, 2, 3, 4. And I know that on carbon 1, I'll number it here, 1, 2, 3, 4. On carbon 1, just as we have here, I just need a double bond to an oxygen. Draw a little more straighter of a line there. Like so. And that's it. That's our CLAISEN condensation. So identify the alpha carbon, identify the carbonyl carbon, connect them, number, cut off the ester portion of your ester that's being attacked, if you will. Number the carbon chain starting from the carbonyl carbon. Make sure you have a carbon chain of the same length, and then add a double bond to oxygen at the same carbonyl carbon or carbon 1 of the chain you identified.